All right. Well, hey, everyone. With any luck, for those of you who knows, maybe I'll use these in the future, but this has definitely been more of a COVID-related thing that we've made these videos. So who knows, this could be the last one for a long time. So yeah, it's been a year, and just thank you all for your hard work. You know, it's not always been easy. So thanks for being here. Thanks for being awesome. All right, well, let's go ahead. Let's begin. Today we're going to talk about the seasons and just kind of how Earth's position in space affects the seasons. And so here we go. We shall begin. Dun, 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 dun. So in New York State specifically, in case you were unaware, we live in New York State. Isn't that nice? And so the seasons, you can almost imagine. So which one do you think is going to be summer? So you look at the sun, you look at its position in the sky, its angle of insolation, and yeah, the one where it's most directly overhead is going to be summer. So June 21st, we get the sun at the highest point in New York State, 71.5 degrees above us. Then March 21st or September 23rd, so the first day of spring and the first day of fall, both will have the same angle of insolation, a little bit less than summer, 48 degrees. That's why those seasons are cooler. And then lastly, the first day of winter, the winter solstice has 25.5 degrees, the lowest angle. So that's why we get the shortest hours of daylight on those days and generally the colder temperatures, right? So cool little fact about this is that the sun is never going to be directly overhead in New York State. So like, you know, if this is the ground, 90 degrees, it will never be directly over your head. So like, you won't ever look straight up in the sky and see the sun directly over you in New York State because we're too far north for that. Because of the tilt of the Earth's axis, we'll never have like that directly overhead sunlight 90 degrees above us. The greatest angle, like we said, is on June 21st, and then the lowest angle will be on December 21st. And every season they change by 23.5 degrees. So like we go back now and we look at these angles, 71.5 minus 23.5 should be 48 degrees, and then 48 degrees minus 23.5 should give you 25.5 degrees. So you can see that they changed, each season changes by 23.5 degrees. All right, so duration just means how long. So insolation, duration of insolation is how many hours of daylight do you get a day? So I think a lot of us can already answer some of these questions generally from our experiences, right? So June 21st in the Northern Hemisphere, you can see that when the summertime, we're tipped towards the sun. And this is why we get increased duration of insolation and also increased intensity, because it's like you're leaning towards the sun. So you're gonna get more, an increased angle of insolation. So we have longer daytimes than nighttimes. All right, and so you also notice though that the Antarctic circle, so 66.5 degrees south up to 90 degrees south, is completely in darkness. So during our summertime when we have longer days, if you were living in Antarctica, you would have shorter days and it would be in complete darkness. So the North Pole during the summertime is going to have, look at that, the whole North Pole, and actually the whole Arctic Circle and above, 66.5 degrees north and up to the North Pole, is all exposed to sunlight there. So they actually get 24 hours of daytime. Kind of wild, all right? New York State, we get up to about 15 hours of daytime. That would be in this area. Then the equator is always equal. So if you look here, if you measured this line, and you measure like this line, the equator is in the equal area, equal equator. And then 90 degrees south, the South Pole, gets 0 hours of daytime because it is all the way at the leaning away from the sun. All right, December 21st. So notice here now the North Pole, we're tipped away. That's going to be our winter time in the Northern Hemisphere. So we'll have shorter day times than we normally do. So our nights are long, our days are short. And the area north of the Arctic Circle, again, is going to be the opposite that it was before. It's now in complete darkness. So it's getting no hours of daylight. So it's literally 24 hours of darkness. Wild. I've always wanted to be there for that time of the year. I have not. So 90 degrees north, again, look at that, 0 hours of daylight. New York State is going to get about 9 hours, and you can visualize it, right? Like there's less here in the daytime and over here that's in the nighttime. So more hours of darkness, fewer hours of daytime. Equator is still equal. And the South Pole is now completely in the daytime. So we will get 24 hours of daytime. Now, it's not going to get hot there. You might think, well, why isn't the poles hot? That's because the angle of the sun is always low. So it's always getting low sunlight. So even though it's getting 24 hours of it, it's kind of like a bright light versus a really dim light. So it's very strong. All right. During the spring or the fall, it will be even. So you can see here, it's even now. I want you to pay attention to something. This diagram makes it look like the tilt of the Earth has changed, but it's not. It's just that if the Earth is always tilted, what's happened is you're just kind of looking at it from the side view here. So this view makes it look like the Earth's axis has changed, but it's not. It's just that you're looking at it from this side, and so you don't see the tip, but it's still tilted the same. It hasn't changed. It's still, the Earth's axis is still tilted at 23.5 degrees. Okay. But it is kind of cool. They're called the equinoxes on March 21st and September 23rd because you have 12 hours of daytime everywhere on Earth on those days. So the North Pole, you get 12 hours. New York State, you get 12 hours. Surprise, surprise. At the equator, 12. And at the South Pole, 12. Okay, so here's a picture that just kind of shows you a different view. And you can see, okay, in June, right, tipped towards the sun. In the winter, notice that the angle never changes. So it's tipped to here, go over to here, it's still tipped the same, right? It's just that we've moved to a different, now we're next to the sun. Now we are over here, we're still tipped the same, right? The Earth axis isn't going back and forth. Now it's over here and we're tipped away from the sun. And then we go over to March and we're getting equal amounts of sunlight there. All right. So how could you, if you were just looking at like a picture, how could you figure this out? A couple of the ways. One is the North Pole during the winter time is always pointed away from the sun. That's an easy way to figure it out. And during the summer, the North Pole is always tilted towards the sun. So, and then the Earth is going to go, revolve counterclockwise around the sun. So the Earth revolves counterclockwise around the sun. So let me just show you what that looks like. So it's like, oh man, look at that. They went and made the diagram a little different on us, but we know that this position here, we're tilted towards the sun at position C. So that's summertime. Here, the North Pole is tipped away, so that's winter time. So if we go around, December 24th, always pointing away, June 21st, and then after June comes fall. So D will be the fall time, and yeah, so March 21st for here and September 23rd for position D. That might not make too much sense. We kind of went through that quickly. Don't stress. Okay. So last thing before we go, this one's a little bit longer, so sorry. I know you're like, man, I need to get back to my show or play more PUBG or whatever. So how would Earth seasons change if there were no tilt? So the last thing would just be this, like there'd really be no variation because you'd never really be closer. It's not so much the closer, what I mean to say is you'd never be, your angle of insolation would never change. So you'd always be kind of the same tilt next to the sun, right? And so you'd never have that where you're leaning towards the sun versus leaning away from the sun. because the seasons really vary based off of angle of insolation. So when we're leaning towards the sun, we get more direct rays from the sun and it's hotter. When we're leaning away, we get less direct rays and it's cooler. So if there's no tilt, there'd really not be very many seasons. Like it might be a small variation, but it would be certainly no summer, spring, winter, fall kind of like we're used to. Yeah. And if it was greater than it, then we would get greater seasonal variation, maybe even some really, really extreme temperature variations, like really hot summers and really cold winters. Okay, I'm gonna put this for you as a page for you to look at later. Just kind of a graphic organizer way of summarizing what we've just talked about. So I'll put this for you so you don't have to like screenshot this or something. I'll send it to you in a little bit. All right, everyone. Well, super. Thanks for being so awesome. And yeah, that's it. I'll see you in class or wherever.